Hello guys, I'm going to tell you something about Meteor deployment and challenges we faced while doing that. And maybe to begin with, I'm interested, do you know maybe how many of you are familiar with Docker, like technology? Okay, because the presentation will be highly tied to this topic. And so what was our problem? So as Tobias already said, we're not limited only to the Meteor application. We have dozens of microservices which are supporting Meteor, which are extending its functionality, which are making sure that our Meteor application is not bloated with a business logic. So we spread it across our different microservices, and we found a nice way to deploy them. And later we wanted the same way to deploy our Meteor, the same easy way as we can deploy our microservices. So the challenges we had is, so as I already mentioned, also very frequent changes. If you deploy microservices, it means that I make some changes to the code, Mikita make, and my teammates make a lot of changes, and it needs to be deployed as soon as possible because it's a rapid environment and we want to move quickly, and so you know what I'm saying. And it requires many same tasks, because who likes to deploy it manually? It's always boring. So who is a developer who don't like to automate things? So we think the same, so we want to automate our deployment, and we did it. Also, it's obvious that manual process, it implies that there will be errors, because we're all humans, we can mistake. So let's shift this burden to the machines instead of do it manually. So how we came up to the solution? In one word, it's Docker. So you guys who know already about Docker can already imagine. For those who don't, I can explain a bit. So it tries to package your application in some sort of Linux container, which actually looks the same whenever you put inside. So you can deploy, you can store, you can spread in the world without caring about the end user, because end user always have the same interface to interact with your application. So Docker also requires one thing, that now it's a developer's responsibility to set up how your app should be deployed. So now every developer of a single, whether it be microservice or Meteor application, doesn't matter, he has to define how your app should be set up in order to be deployed. So from inside you set up low-level things. From outside you receive a standardized container which can be easily deployable. Also, it has a lot of benefits about dependency. Maybe it isolates your environment, isolates your unique dependencies of each your service in its own container, so it's not accessible from other containers. So in most cases it's good. And it gives us repeatable builds. So I can build a Docker image and you can pull it and run it locally without caring what's inside. You know how to do it just. So that was about Docker. So Docker itself is it will package our Meteor application, but we need to build it. We can do it locally. I'll show later how to do this, but clever people invented better things, so do not reinvent the wheel. There are, the Travis, which most widely spread used for open source applications as a continuous integration platform, who just pulls your code, build it into the artifact, and also it can run the tests. So we choose the Wercker. It's a relatively new service, and it has a lot of benefits, I will say why. So first of all, it was built completely about Docker. So maybe previous continuous integration solutions, they were not specifically intended to use with Docker. They were intended to use maybe for other purposes. So Wercker is new, so it just says that, okay, we see with the Docker the future, we'll do one thing, and we'll do this one thing well. It was built to ease the suffering when you when you orchestrate your large amount of microservices, because when you have a single application, Meteor application, it's relatively easy to deploy it even manually, but when you have it, your logic, your application scattered among the like 20, 30, 40 servers, it's really hard to automate. So the more services you have, the harder it is to automate the deployment of them. So Wercker comes here with the rescue. It introduces his own way of own level of abstraction over the deployment process. These things called workflows, pipelines, and steps. I also show later what does it mean, but it's great thing. And also Wercker comes with great things such as own registry of ready-to-use steps you can use for deployment, whether it be to publish your NPM package, whether it be upload your artifact to S3, whether it be maybe notify you in Slack when your build is finished. You have these small steps already written by other developers. You can just add it to your config file and use in your development process. And I didn't mention, but it's free even for unlimited private repositories. So I ask you to try it. Maybe you'll find it useful for yourself. So no need to pay. How do they earn money? The only limitation currently they have that you only can run one concurrent build, and it's when you have 50 services, it's one concurrent build, it's really hard limitation, so they make money on this. And so this was about building. So we already packaged our Meteor application. We're not, but I described you how to. We can build it, and now we have to store it somewhere. Firstly, we have to store the Docker image we built. We came to the AWS as an established solution for this, and it provides us an Elastic Cloud registry. It's like maybe like Docker Hub, yes, it's Docker Hub like GitHub, like a place where you can store your built images. You build your app, it's like an artifact, and you can store it there, different versions, like in your Git repository. So a huge benefit for us was, and a requirement, that it resides on the AWS architecture, so it can easily interact with our other parts of applications. And there comes ECS, Elastic Cloud Service, which basically manages your images, manages your cluster services. It's just a thing you need to actually deploy to host your application. So now I'm going to show how it looks in real life. So enough theory. We'll build a simple Meteor applications to show you how the overall process can look from the beginning to the end. So we begin with a Meteor create. It will create a, all know this basic application with a button. You click and the counter increases, and this app will be used in the example. So our app is ready. You can imagine I'm not going to show you real life in real time in the IDE. So just look. So you can now, at this moment, you can launch it locally. But we want to ship it, we want to package it, we want to deploy it. So we need a Docker for that. Like what you usually write in a Docker file. A Docker file is a file which, like Docker, it reads it and then it knows how to interpret your code and so do the things. So probably you all know the Arun Noda from Meteor community, famous guy from Kadira, and so on. So he also faced with this question, and he built already ready to use Docker image which you can use as a base for your application, which under the hood does all the low-level stuff you need, like downloading Meteor, building it, installing NPM dependencies, and maybe connecting to Mongo, and so on. So we can begin with just one-liner Docker file, which under the hood looks like a few hundred lines, which will allow us to build our application, to package it into the image with this command. It's pretty simple, and so we package it and we can run it. We run it and just saying that it will run on the default 80 ports on localhost, and the name of the image we set. This I can show you, maybe even, or I don't know. So as a next step, we need to set up our things on AWS. Firstly, it will be ECR, container registry. It's not worth even showing, because you just set the name and you'll have a, maybe you can call a URL where you can push your just locally built image. And so the next step is to define your ECS. The step is a bit complicated, but also doable, like during the evening, like I did yesterday. So you define a cluster where you, like a cluster with the instances, will just define one instance, one server, which will run inside our Docker image. Then you have to define task definitions. It's also like a terminology used by AWS. I'm not going to dive into this, but basically it means that it's just a JSON file which is common. It looks similar among the other hosting providers. Maybe if you are familiar with others, you can find the similar things. Here you define the port mappings, the name of application, environment variables, and stuff like this. And the most important is in the bottom, where you define the path to your Docker image. So this file will be stored inside our Git repository in order to Wercker to pull it and to use for our deployment. And the last step, we define a service. Service is another terminology in the AWS, which means that it means how we manage the tasks, how many tasks we want to run. So it means how many applications we want to run, and as you see, it's so. Okay, the next thing is Wercker. There's a lot of steps, but I saw that too, that why do I need to do all the steps? It's boring, but in the end you'll realize that manually deploying is more boring, and it was going through all the steps. So we go to the wercker.com, we create an application, choose a Git repository as a source of our code, we don't define at this step nothing, we just create it. But it will do nothing. So we have to say Wercker somehow how to interpret our Docker image, because it doesn't know. So we can go to the wercker.com, to the setting page, to the workflows. Remember, I said in the beginning about the workflows, pipelines, and the steps. So basically, this workflow is the way you say, Wercker, do this thing, then another, and maybe you can branch from one step and do different things. So it's like easier way to organize a complex logic you need to in order to deploy a lot of services. So Wercker workflow on the monitor is horizontal, on the horizontal axis, and the pipelines are defined like build, push to ECR, and deploy to ECS. So pipelines is a set of steps. Steps can be like git pull, cd into like change current directory, Meteor build. So the most low level things, these are steps. They are organized into pipelines, and so here we have a build pipeline which will do the building of our Meteor project, including download the Meteor distributions and removing it because we don't need it on the production run server as it compiles to the node application. In push to ECR pipeline, we'll define that we want to to push our image built with the previous step to our container registry. And the last one is deploy, so it will basically say that we will take our task definition described on the previous slides and put it to ECS in order to deploy. So you can look that you don't need to configure at all anything here. So build pipeline, it'll just say that in our configuration file inside the repository we will run the build command, push to ECR, it has some environment variables like AWS keys, secret keys, registry IDs, like so, and that's basically all. The next step, we'll write our Wercker configuration YAML file in our repository. It will, so we'll define our pipelines, we'll define our steps, and I'm going to show you this. So it's, if you look, it's really straightforward as for me. It's our sample meteor application I created some time ago. So it contains like the default files you know, and Docker file, as I said, it's just one-liner. It just and task definition and Wercker YAML file. So the first step is to define the base image which we'll use for building our image. A base image, maybe I missed this in the beginning, I had to say that it's like under the hood, like some Linux distribution installed with some dependencies you need in order to launch your application. So for Meteor it will be, if I'm not mistaken, like some sort of Debian with installed Python, CURL and such things that needs to build your Meteor project. The next step is a build step. The next pipeline is build pipeline. So pipeline can be considered as a like basic Unix programs which have some input and they have some output. So as you can see here, this environment variable defines the input for our pipeline. Here will be stored our Git repository source code, and we will just copy it to the app folder for convenience of the build script we use. So and here the most important is this line where we actually run the build script, which will download Meteor, install it, and move the bundle to another directory, output directory. So it's needed in order to the next pipeline to receive the output from previous pipeline and have it as a input. The next pipeline is a push to ECR. So as you can see, this is a step from Wercker steps registry. As I mentioned in the beginning, any developer can write a deployment step, which is used maybe very frequently among other developers, and share it so other can use it again. And as probably the most use is step which will push our image to the container registry. Container registry can be either Docker Hub or ECR in our example. Also it contains, so it's a command to run our applications, directory, ports, tag, and like other things. And the last one is our deploy to ECS. So as you remember, we have our task definition. It's pretty small. What we do here is just replacing some placeholders with maybe sensitive information with environment variables defined in the Wercker interface, and also using the step from Wercker steps Wercker steps registry. So So it's also easy to push to deploy our image to the ECS. So what it will do under the hood, it will stop our instance, stop our Docker container with our Meteor application. It will populate it with a new one which we built just now, and it will start it again. So since you don't have to care about this, you have just to use already built. So we're going back. We set up our Wercker configuration file, and probably, yes, it's all we need. We can now make some changes to the code, commit, push it, and Wercker will listen to our Git hooks and pull the newest code in order to build it. So let's write something here with Bill. Whatever. So now we can go to the Now we can go to the Wercker interface and see that it picked up, probably. Yes, we have changed title. And it begins to execute our pipelines. The first is build, the next in the queue are push to SR and deploy to ECS. So it will take some time, but not so much, around 5 minutes. You can go inside and look what's happening inside. It will just output the standard output of the Docker container, which is running now on the Wercker infrastructure, which is actually now building our application. So you see it downloads it not latest Meteor, and we'll try to build our project. So meanwhile, I can go back and summarize. So what we did, we Dockerized our Meteor application. I didn't mention a lot of other benefits which you gain doing so, but believe me, there are a lot of them. We deploy and build our image with Wercker and use AWS solutions such as ECR and ECS to deploy it. As maybe like overview of all I described can be like build test. I omitted the test step just for the sake of the example, for the sake of the simplicity. We push it to ECR and deploy. And meanwhile, so some progress here. Yes, as we can see, it was successfully built. It was pushed to the registry, and now it's going to be deployed. So the latest version deployed here is basic, just with Meteor. If everything will succeed, we'll see page will automatically be reloaded, and we'll see the updated title we set in the code. So what's happening? We have just wait, or maybe, I don't know, re-trigger it. Oh, I clicked 2 times. I'm trying to speed up, yes. It helps to speed up. So as you see, it's only one concurrent build, so if you build something, another in the background, it will just wait for a long period of time. So yes, that's it. And so some resources are not so much, but it's pretty enough to start. It's pretty enough to do what I did. It's enough to go go later. So it's Meteor, Docker official site, where you can be introduced with Docker philosophy. The next is a link to the GitHub repository with a Docker image from our node, which will build our application. It's Wercker and it's Amazon. So thanks for attention, and so
on your slides you violate material design from
I know I'm a rebel. So it's almost succeeded.
Meanwhile, you can ask questions before writing of build.
Yes, later I'll probably publish like a detailed guide, a detailed how-to to my GitHub, so you can follow for the updates and eagerly wait when it will appear there.
Did you review more traditional tools for continuous integration and deployment, such as Jenkins?
Not actually, maybe. Yes, I had a glance at them and like I read through them. They're in like how it's called, introductions and so on. So you want to say that there is something better?
I think it's more flexible. Actually, I'm a developer working with Jenkins on REST infrastructure. For example, email notification
Yes.
or flexible way of setting up builds, execute shell scripts, everything else.
Yes, and everything this is present into Wercker too. It's the same notification, email, Slack, whatever you can imagine. Also, a lot of here, if you go to the registry, it's thousands of already ready-to-use scripts from developers all over the world. So you can set up it just in few lines to whatever. For example, for Makita, it pushes a Chrome extension to the Chrome Web Store, or like everything. So I don't think that I lose anything. So yes, so we see our changes successfully pushed, deployed, and with no suffering, with just pushing and enjoying how it's been deployed.
I have two questions.
Yes.
They are not about deployments, they are about your applications architecture in general. Are all of your microservices Meteor apps and
What?
all of your microservices Meteor apps? Are they?
No.
And how do they communicate your microservices via HTTP, DDP, Mongo, or something?
Yes. So the first question is that no, Meteor is only unique one among others. So all other are like pure Node.js applications which help Meteor to carry maybe heavy things which it doesn't want to know about. And another, so communication with microservices is a topic for maybe a long discussion as a next presentation, but generally microservice architecture, it implies that they have to communicate over like lightweight protocol, yes, HTTP, but besides of that, it can be abstracted in whatever you like. So we use HTTP for some communication, from other communication we use different queues. So for there are reasons. So I answered, I guess.
Databases each for one microservice, or you have common?
It varies. It varies by the patterns, like good patterns of microservices have to be. You're prohibited to share a same database among different microservices. They have to be as dumb as possible, but no one forbids you. You can use the same database among some microservices. You can use a different one, and that's the great thing about microservices. You can use whatever database you want in one microservice. It will communicate over a lightweight protocol with others, and they basically don't know what to use under the hood, because they can use the best tool they think it's the best tool which fits the needs of the specific microservice. So, okay, I hope you enjoyed, and after our meeting you'll go and automate every deployment you have.